inductive reasoning. Okay, this is all kind of the start of proofs. We're not really doing proofs yet, but this is the start of it. A conjecture is an unproven statement that is based on observation. You use inductive reasoning when you find a pattern in specific cases and then write a conjecture for the general case. To show that a conjecture is true, you must show that it is true for all cases. You can show that a conjecture is false, however, by simply finding one counterexample. A counterexample is a specific case for which the conjecture is false. For example, you're outside, you're like, all birds can fly. You've seen a bunch of birds fly, that's a guess based on observation. Well, you see a penguin, that's your counterexample. Penguins don't fly.
Dead birds can't fly.
And dead birds can't fly, true.
The angry birds can't fly.
I should say all live birds can fly. All right, we're going to describe this visual pattern. Describe how a sketch of the fourth figure in the pattern would be. So we are looking at it. It's based on observation. We see three different figures. One is divided in half, and half of it's shaded. One's divided in fourths, and a fourth of it's shaded. One is divided into sixths, and a third of it's shaded. So what would the fourth one be divided by? Eighths. So you have a circle. We've got 1 line, 2 line, 3, and 4, and you'd have one section shaded. Okay. Any questions about that? Seems pretty simple. All right, example 2. I hate this program. Hold on 1 second.
If we're doing this on homework, do we have to describe this, like when you said that they're divided by 2, so do we have to actually write down?
If it says describe, you would have to describe. If it says just draw, like this one does, then you don't. Well, actually it does say describe, but we described it out loud. If it's on your homework, you have to describe it in writing, because I'm not there with you. Okay. So we're going to make a conjecture. We're given 5 collinear points. Make a conjecture about the number of ways to connect different pairs of points. So we have 5 collinear ones. That means they have to be in the same line, right? We want to know how many different ways, the number of ways to connect different pairs of the points. So we could do it this way. We could do one this way. Right? How many different ways do you think we have?
2.
I see 2 so far. What's a third one? We've got to connect pairs of them.
So like diagonal? Like triangle?
Could we do this?
Yeah.
I mean, it doesn't say anywhere on there that we can't, right?
You do like this?
So we could do like these ones, right? How many different ways?
A lot.
Can we think of how many different ways? Right there, there's 4. How many points are there?
5.
Okay, and one point can be connected to how many different ones?
4.
4. So there must be
5.
20 ways, right?
5 times 4.
Right.
Wait, how'd you get 20?
There's 5 points, and each point can be connected to each of the others. Each point can be connected to each of the others. Each point can be connected to each of the others. So there's 4 different points that the first point can be connected to.
Oh.
There's 5 points. All right, a student makes the following conjecture about the sum of 2 numbers. Apparently it's not on here. Find a counterexample to disprove the student's conjecture. This is the conjecture. That
2 numbers. Wait, what's that?
a student makes the following conjecture, but that following conjecture isn't up there. But this is what it's supposed to say. That any 2 numbers added together, their sum is greater than the 2 numbers.
That was a warm-up.
Yep. So do we remember what the answer is?
Wrong.
1 must be a negative.
If 1's a negative, then this conjecture is false. So if I had 2 plus -3, my answer is -1. -1 is smaller than 2. Yes?
I'm thinking number 2 is wrong.
what would the answer be then?
Well, because if you connect them 4 times, then you can't connect it a second time, so it would be.
So the first one would be 4 times. The second one would be
3.
The third one would be
2.
And the last one there would be 1.
1.
So 4, 5, 6, 7, 8, 9, 10. Does everybody see what Nathaniel's showing?
But you can connect it one more time, like the middle one can connect to the last.
Okay. If we have, let's try this. We've got, this is why math is fun. We've got 5 points, right?
Yeah.
The first one can be connected 1, 2, 3, 4. So there's 4 ways. The second one, we can't go backwards and connect it to the first one. That's the same thing, right? So then we've got 1, 2, 3. Well, then the second one we can't say to the first one or to the second one, so the third one only goes 2. Which means the last one has...
Wait, but you didn't connect the ones in the middle.
Yeah, I did. This one goes to this one.
Oh.
Can you skip?
So we went from 20 to 10. This one can go to this one, this one can go to that one, this one can go to that one. So there are only 10 ways.
So you.
Nice. Okay. Yes, I was. All right. Does everybody know what tomorrow is?